Cisco Extended Detection and Response, or XDR, where to capture NetFlow. So I also have to advise you that I am in fact a Cisco employee, but the videos I'm creating here and anything I say in no way represents Cisco or Cisco Corporation, and everything is entirely me. So the question I often get from my customers is, how do I configure NetFlow to send to my P&M sensor or some other type of NetFlow exporter? And the question is easy to answer. I can give them a template to show them how to configure a switch or give them a guide on how to configure a firewall or something. But the question I really want them to ask me is, where do they need to configure to capture NetFlow so that we can capture all the traffic that we need to have a full conversation of what's going inside of our environment. And that's really something that I generally have to initiate. I'll tell them, how to do it real quick and everything because it's an easy answer. But then it's like, now let's discuss where you're going to do this at. And it's a very important conversation. And this is the PowerPoint that I actually use when I have this conversation. I'm going to walk you through it real quick. And this is obviously a very much stylized implementation. So we got our firewall up here, our core switches, our distros, and campus access switch area, campus wireless over here. These are all our endpoints, and they're not always workstations. They could be IoT devices and everything. Over here, think of this as like your data center. You got your data center distros, data center access switches, virtual server. Now, I'll probably talk mostly about ESXi. That's still what I run into the most, though I'm seeing a lot more Nutanix and Proxmox. But these are like the physical servers right here, the physical servers that all of these virtual machines actually reside on. All right, so here's the key. When you're capturing NetFlow for your environment, and before I go too far, obviously I said, nobody's environment is like this. It's never this perfect. But in your environment, you're going to have to make some decisions on how your traffic is flowing and where you're going to capture it to make sure you see a full conversation for all of the communications inside there. And I know it's not going to look like this. It's not going to be this clean, this perfect. But so let's just pretend like your environment's like this. Okay, so the key word here is at the edge, as close to the edge as possible for every edge that you see. And where is that? That's your campus access switches, your wireless, your virtual distributed switch inside your ESXi servers, and your firewall. And what does that mean? I don't really need it at my cores. I don't need it at my distros if I can capture all of these edges. Okay, let's do a little internet communication that's like a perfect conversation of some kind. Let's say this little guy down here wants to connect to something on the internet. What's the first thing he does? He's going to um, reach out to his DNS server to try and resolve a domain name to an IP address. If the DNS server has it in its cache or something, it's going to provide it back to him. If it doesn't, it's going to then reach out from itself to an internet DNS somewhere to get that IP address back. But look what we're doing here. If we're capturing at the edges, we're going to see this full DNS resolution, everything that they tried to do. And then as soon as he gets his IP address, he's then going to say, okay, great. Now I'm going to go out and we're going to see this full conversation because we're capturing here and here. Now I know this is like, in a perfect world, we're able to get this entire conversation. So the problem is that it's never a perfect world, right? So let's talk about what we do instead of that if we don't actually have a perfect world. So let's say these are some kind of dumb switch. It doesn't actually do NetFlow or anything. So what might we have to do? We might have to go back a step to capture at these distros. Now the distros are a bigger device, has more capabilities associated with it, and so in order to see the conversation, we'll do this. We'll do our capture at the distros and that's going to be just fine. It's not as good as the Edge, but it'll be okay. Now, why is it not as good? Let's say this guy somehow gets infected with malware. Somebody finds a nice USB stick in the parking lot that says Bitcoin on it, and he brings it in, plugs it into his device. His EDR doesn't, see anything malicious on it, but it still gets infected, and this thing actually starts trying to reach out to all the other devices laterally in its own subnet. And everything in the subnet is on this particular campus access switch. So what's going to happen is he's going to be pinging over to this guy trying to make a connection. This device does not have NetFlow running on it, so we'll miss that conversation. We will see the conversation when he, say, tries to jump over to this guy here. So he goes up here, we get him at the distro, and he comes back down to this particular access switch and over into here. So we do get to see that. And before you say, yeah, I know there's not enough lines connecting everything, it just gets too cluttered if I put too many more lines. You get the idea of how these are, this isn't like exactly what yours looks like. I know you probably have a lot more cables in there. Okay, point is, we won't see it until he starts moving into, say, another subnet, because he's been ARPing up to this point, and now all of a sudden he's going to go to his default gateway. Default gateway goes up here into the distro and then back down to this other access switch. Then we see that conversation or something like that. So that's kind of one of the points is get it towards the edge if we can for everything. So I hope that makes sense. Okay, let's talk about another interesting scenario that kind of pops up and the reason I say if you're like using an ESXi environment to try and capture your NetFlow at the virtual distributed switch. Why is that? If this is the physical ESXi server, we can have multiple VMs running on the same physical device. In a scenario such as this, if this VM needs to talk to this VM, this is a domain controller, this is your DNS, and it's running on a different virtual machine, and they're somehow talking to each other. If you're not capturing until you get to that access switch, that data center access switch, you're going to miss that conversation. And again, it's the same kind of thing. We don't want anything spreading inside of our environment without seeing it as close to the edge as we can. So if we want to see the communication inside an ESXi server and you have a virtual distributed switch set up in your environment, it gives us NetFlow and we can do something like this. We can capture that particular communication. So after explaining where to capture NetFlow, this is another conversation I usually have, and it's a discussion on a feature available in XDR Analytics called passive DNS. And what does passive DNS give us? There's some alerts that are associated with passive DNS telemetry, and it also allows us to use the IP domain and watch lists and third-party watch lists feature. Now, I'm not going to go into too much about those watch list features, but to say that they can easily include, IPs and obviously IPs and domains on the first one there, but they can, the domain name piece is what's important here. So remember, if we're sending telemetry, which is NetFlow, and NetFlow is those basic 9 tuples, source and destination IP, source and destination port, protocol type of service, that kind of information. There's nothing in there about payload. That's all header information. So in the DNS requests are in a payload. So if we send NetFlow, we're not going to see this and we're not going to be able to use it. So what we're going to do now is talk about how we can take advantage of those particular features. And that methodology is passive DNS. Okay, so in order to take advantage of those watch lists and the associated detections that are related to passive DNS, let's understand where passive DNS is. Right here, I'm looking at the XDR Analytics Advanced Configuration Guide. And if we scroll down a little so that we're looking for Appendix C services. So let's click on that. It takes us down here, and this is it here. PDNS Capture collects passive DNS queries. So in order to give it the best advantage that we can, we need to make sure that we're going to get all of those DNS queries that are going to whatever resolver we're using in our environment, whether it's our enterprise DNS or an umbrella virtual machine or something like that. Whatever you're using in your environment, we need to see all of these. And this is one way we can do it. So right here, you're looking at this. This is our little P&M sensor over here. We're working with in like an ESXi environment again with the virtual distributed switch. And the blue line here is representing NetFlow. So we're sending NetFlow from this virtual distributed switch. But, as we said earlier, NetFlow does not have all those DNS queries in it. We're just seeing the 9 tuples that are coming from regular NetFlow. In order to see it, we need to span over or port mirror all the traffic going to our DNS server, whether that's our enterprise DNS servers or umbrella VMs and such. We span that traffic over to the PNM sensor. Now, I think in other videos you've seen me where I've shown you can span everything over to a PNM sensor, and it will turn it into NetFlow and send it on up into the data lake. If you're doing something like that, you're obviously already getting all of your DNS stuff as well. But if you're using NetFlow from here, in order to take advantage of the passive DNS features, we still want to span over all the traffic going to our DNS servers. And this is how I usually tell people how to do it. You're going to have at least, add a second NIC to your PNM sensor. Any NIC that you enable inside of your PNM sensor is going to, by default, be in promiscuous mode. So you could send everything to one NIC like this. You could send NetFlow and you could do the span. This is what I'd recommend though. NICs are, virtual NICs are pretty much free. So make 2 of them. One is going to get an IP address. We're going to send all our NetFlow to it. It's going to do all our command and control of this particular device here. It's where we SSH into it. Span the other traffic to it or port mirror to the second NIC. You don't need to give it an IP address. That way you can flood this particular NIC with everything that you may be wanting to send to it and not ever overflow the NIC that's taking in all the net flow from probably your entire environment and what you're SSHing in so you can control this PNM sensor. So in summary, net flow from your virtual distributed switch into the PNM sensor on NIC 1 that has an IP address. Port mirror all the traffic going to your DNS server to NIC 2 that you don't necessarily have to have, or you actually don't want to put an IP address on. So this is a quick look at IP and domain watch list, and you can see in here, I don't have IPs listed here, but I do have domains listed. And how else is XDR Analytics going to see those domains unless it sees those DNS queries that are going to your DNS server and able to actually look at the payload in there to notice that, somebody's trying to get to these domains that I've identified. If somebody tries to connect to them, I want to get an alert on them. So in this particular case, all these domain names, if I did not have passive DNS set up in such a fashion that it's going to see all that traffic, these are never going to actually trigger for these because it's never going to see those name resolution requests. And here's a quick look at the third-party watch list feature. In this particular case, instead of listing out all the domains or IP addresses like you saw in the previous example, you're actually going to connect to a URL. And from that URL, you're going to pull down, IP address and domain names that you want to trigger a particular alert for. So in summary, capture telemetry, your NetFlow, as close to the edge as possible so you can see all conversations, both east-west and north-south inside of your environment. And secondly, span or port mirror over traffic going to your DNS servers so you can take advantage of the passive DNS capabilities of XDR Analytics that not only include those detections, but also the IP and domain watch lists and the third-party watch list capabilities of your XDR Analytics implementation. So I hope this was helpful. I know it's not as interesting as some of the other videos where I actually do something on the command line. And I didn't talk about the IP and domain watch list and the third-party watch list too much before. Didn't really explain everything about those features, and I'll probably do that in another video series. I haven't actually done anything on the capabilities of XDR Analytics. Everything up until now has just been about setup and getting telemetry into the environment. But I haven't really talked about, once you have all that telemetry in there, what do you do with it? And I'll probably start making some videos on that as well soon.